Hello everyone. Welcome to the solution of LeetCode problem 901 named Online Stock Spun. In this problem, we have to design an algorithm that collects daily price codes for some stock and return the span of the stock price for the current day. Here, the span of the stock price in one day is the maximum number of consecutive days starting from that day and going backward, for which the stock price was less than or equal to the price of the current day. For example, if the price of the stock in the last 4 days is 7212 and the price of the stock of today is 2, then the total span of today is 4. Because if 2 is stand after 212, so total span is 4. Because starting from today, the price of the stock was less than or equal to 2 for 4 consecutive days. Also, if the prices of the stock in the last 4 days 7, 34, 1 and 2, and the price of today's stock is 8, so here the total span is 3. One is for 8 and another is for 1 and 2, because 1 and 2 are less than or equal to 8. So in total span is 3. So here we have to implement the stock spanner class. Now inside the stock spanner class, we have to implement the next method. Here the next method returns the span of the stock price given that today's price is price. That means we are given the today's stock price and we have to return the span of the today's price. I hope you understood the problem statement. Now let's move on to the algorithm. Now, to understand the algorithm, let's take this example. Suppose the last 4 days stock price is 7, 34, 1 and 2. Now, if today's stock price, suppose it is 8, it is today's stock price. So what is the span of the today's stock price? It is 3, because the maximum length is starting from today to backward, where the stock price is less than or equal to the today's stock price is 1 and 2, because 1 and 2 are less than or equal to 8. So here we can see that for the stock 8, the total span is 3. So how can we solve this problem? By using some of the data structure. Here we can use the monotonic stack. Suppose this is our stack. Now in each of the stack, we will store a pair of the values. In the first pair, it will be the price, which is given, suppose 7, 34, 1, 2, and so on. And in the second input will be the corresponding span for this specific price. So here, for each of the element of the stack is the pair of value. The first element of the pair is the corresponding price, and the second element of the pair is the corresponding span for this specific price. Okay, so far so good. Now let's dry run the algorithm. Suppose currently we are at this element 7. So here for the element 7, the total number of span is 1 and price is 7. So we have to add 7, 1 here. So we are adding 7 and 1 because the stack is initially empty. So far so good. Now for this element 34, we have to determine what is the span for this element 34. So here the span for this element 34 is 2. because we have two elements which is less than or equal to 34. So here we have to add 34 and 2 into the stack. But before that, as we have used 7 in our span of 34, we have to remove 7 and 1 from the stack and add 34 and 2 into the stack. So far so good. Now for this element 1, we have to determine what is the span for this element 1, but there are no element which is less than or equal to 1 before it except this element 1. So here the span for this element 1 will be 1. So we have to add 1 and 1 here. Now for this element 2, the span will be 2 because there are two elements which is less than or equal to 2. It is 1 and 2. Or we have to check whether the first element of the stack top element is less than or equal to 2 or not. If it is, in this case, 1 is less than is equal to 2. So we have to erase the top element of the stack and insert the element 2 and 2 into the corresponding stack. So far, so good. Now, for this final element 8, we have to determine what is the corresponding span for this element 8. So here the corresponding span is 3 because there are 3 elements which is less than or equal to 8, which is 1, 2, and 8. So we have to check whether the first elements or the first element of the stack top element, which is 2, which is less than or equal to 8 or not. Yes, it is less than or equal to 8. So we have to add the answer, which is the second element 2 plus the 8 itself. So it is one element, 2 plus 1, which is 3. So here, as we have used the stack top element, we have to remove the top element and add the element 8 and 3 into the corresponding stack. Now we have reached out of bound and we have completed all of the iterations. So here, what is the corresponding second element of this element 8? The corresponding second element of this element 8 is 3, which is this 3. So here, for this element 8, the span will be 3. I hope you understood the algorithm. Now, the overall time complexity of this program is big O of n, and overall space complexity of this program is also big O of n. Because we have to use extra stat to solve this problem. That's why the space complexity is big O of n, and the time complexity is big O of n also, because we have to iterate each of the element of the corresponding input. I hope you understood the algorithm. Now let's move on to the code. In this problem, the code is pretty simple. We are given a function named next, which has a parameter price. Now here we have declared a stack which will store the pair of elements as the element. Now, initially the answer is 1, which is default for the 1 price. Now we have to repetitively check whether the first element of the stack top element is less than is equal to price or not. Yes, it is. That's why we have to add the corresponding second element of the top element to the answer and remove the top element of the stack. Now after that, we have to insert the pair of price and answer to the stack. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching this video. We will get back soon with another LeetCode solution.